Okay, so the first thing that we need to do is we need to go out here to Google Classroom, and we need to go to the source code, and we're going to click on source files, and we should see chap3.zip. We do that, we're going to come over here to the right hand side, and we're going to, on this symbol right here, this is the download symbol. Let's click on that. And it looks like it's there. And then we're, yep, chapter3.zip, yep. And once you have it, yeah, just click on the download icon, this icon right here. It's arrow pointing down into a little, okay. Yeah, we'll do this every Tuesday night. Once you got it, then you'll click on File, Import, and under the General folder, you're going to click on Existing Projects into Workspace. And we'll click Next. And we're going to make sure we have Select Archive File, and right next to that, we're going to click Browse. And mine automatically goes to my Downloads folder. Yours might do the same. And you should see chapter3.zip. And select that and click Open. And then come down to the bottom, that should see chapter 3 right there. We're going to click Finish. When you click File, you click File and then Import. You did it last week. Oh, you do? Okay. Okay. Okay, so here we have simple decision structure. So this is what a flow chart would look like for a decision structure. It basically says, is it cold outside? If that is true, if it's yes, we're going to wear a coat. If no, we're not going to do anything. We're just going to keep flowing. And so that's the basic bottom line for an if statement. We might even have more basically lines of code if it's cold outside. We might say, is it cold outside? Yes. We're going to wear a coat, we're going to wear a hat, we're going to wear gloves. So this is basically what it looks like. We're going to have an if statement and then a left and right parenthesis. We're going to have what is called a Boolean expression. Boolean means true or false. We're going to ask some type of a question. If it's true, we're actually going to do that statement. Now, the things we're going to have inside of this Boolean expression is we're going to do greater than, less than, greater than or equal to, less than or equal to, or not equal to. Now, this double equal sign, we'll cover that a little more extensively here in just a few minutes. So we might have a situation where we're going to try to see is x greater than y, or is x less than y, is x greater than or equal to y, so on and so forth. So we kind of see the statements we're basically looking for. So let's go ahead and look at average score. So we're going to open up, expand our chap3, expand our src, expand our package chap3, and the very first one is averagescore.java. So we take a look at this, and we've got, again, our class name is called average score. Our executable method is our public static void main. Looks like we've got 5 variables. We've got a double score 1, double score 2, double score 3, double average, and string input. So we're using a J option pane. So since we're using a J option pane, remember everything everything that comes in through a J-option pane is a string. If we want to use it as a numeric value, we have to convert it. So we got J-option pane, show input dialog, enter score number 1. So we bring that in. So input is a string. So we need to convert that input into a double. And the way we do that is we use the double class. Inside of the double class, we have a parse double method. We put the input inside of the parameters for that method. It converts it to a double, and we put it into score 1. We do the same thing for score 2. Enter score 2. Again, we take the input, we convert it to a double, put it into score 2. We do the same thing for score 3. Then we take average is equal to score 1 plus score 2 plus score 3, and then we divide by 3. Then our J-option pane, we're going to show the message dialog. The average is, and then we show the average. And then down here we have our if statement, and it says, if average is greater than 95, then we're going to say J-option pane.show message dialog. That's a great score. Now, just like we talked about last class, whenever we use a J-option pane, we always need to use the system.exit. That makes sure that it closes, because a J-option pane can still run behind the scenes. The system.exit makes sure that it closes and makes sure that none of the J-option panes are running. So we should always use the system.exit when we're using the J-option pane. So let's take a look at this. So if we run this, so I click on the green circle with the triangle in it, and it comes up, we enter score 1. And we're going to put in 78. I hit the enter key. We're going to put in 89. I put in the enter key, and I put 90. I click OK. It says the average is 85.6666, whatever. When I click OK, that's it. Well, let's do this. Let's run it again, and we'll see why we didn't get anything. We're going to type in 99. We'll type in 97, and then we'll type in 94, and then click OK, and it says our average was 96.666667. I click OK, and then it says, hey, that's a great score. And the reason it did that was right here. If the average was greater than 95, and it was 96.6, that's greater than, so that becomes a true statement. It's going to execute this J-option pane show message dialog. That's a great score. So any questions on that? Okay, so as we continue on with this, so we got, so this is what the flow chart would look for the program we just wrote. If the average is greater than 95, if that's true, we're going to display that's a great score. If it's false, we're not going to do anything at all. We might do this. If hours are greater than 40, we're going to basically say overtime equals true. If the value is less than 32, we're going to basically put that's an invalid number. So we can use the if statements to kind of validate things as we go through them. We could say, now notice what they're doing right here in this example. I got if value is greater than 32, system.out.println valid number. Okay, we're going to print valid number. But look what they did here. They said if value is greater than 32, sys.out.println invalid number. So they basically put it all on one line. And that's okay if you just got one simple little if statement like that. But most folks are used to seeing the if statement at least on 2 different lines. Also be careful with semicolons. Notice that the if statement has no semicolon. Only the executable part of the executable line of code that goes with the if statement gets the semicolon. If you were to put a semicolon right there, it would basically error out. It would not be. It would not. This statement would no longer be part of that if statement. Now, here's the problem. If I have more than one executable line of code that goes with the if statement, we need to make sure we surround it with the braces. If I don't, so if I had this thing right here, if sales are greater than 5,000 and I didn't have these open braces and closed brace, only this line, the bonus equals 500, would go with the if statement. The other two would automatically execute, which is why I like to always use braces. And what I mean by that is, even though I have this one statement right here, I like to put an open brace and a closed brace. It always shows where the if statement starts and where the if statement ends. So, is it needed? If you just got one line of code, no, it's not needed. And again, I'm not going to take off any points in any of your homework assignments if you happen to just not use the braces. But I'm just saying I like to use them all the time because it visually shows me where the if statement starts and where it ends. Now, talked about the double equal sign. Whenever we use a compare, in this case we've got a character, and we're going to see if it's equal to the capital letter A. Notice we've got two equal signs. If we use one equal sign, that's an assignment operator. That means if I've got A equals 9, that means that's assigning the number 9 to the variable A. So one single equal sign is an assignment. Two equal signs is a comparison. So just make sure we always know that, because if I try to use a single equal sign inside of an if statement, it will give me an error because it says you're trying to assign that to something else. The double equal sign is a comparison. So we've got the if statement. What happens if that statement is false? What do? Well, we have this thing called the else statement. So it basically says, if something is true, do this, else do this. Meaning if that statement is false, then do this. So let's look at the division program. So let's go to Eclipse. We're going to open up division.java. So, as you all know, if we ever try to do division by 0, that is mathematically impossible. We cannot do it. So here I've got my class called division. Here's my public static void main, and I've got three variables. I've got a double called number1, number2, and a double called quotient. Here's my scanner keyboard. I'm going to ask my user. I'm going to print on the screen, enter a number. And I'm going to ask the user to type down inside the console down here, and we're going to grab the next double and put that in number 1. We're going to then ask them to add in another number. Again, we use the next double. We put that in number 2. Now, what we're trying to do here is we're trying to divide number 1 by number 2. Number 2 cannot be a 0. So look what we do. If number 2 is equal to 0, notice the two equal signs side by side, we're going to print. Division by 0 is not possible. Please run the program again and enter a number other than 0. If that is false, so if number 2 is not a 0, then we're going to drop into the else statement, and we're going to say quotient equals number 1 divided by number 2. And then we're going to print the quotient of number 1 divided by number 2 is quotient. Now notice inside this if statement, I've got my open brace there, and there's the closing brace. For the else statement, here's the open brace, and here's the closing brace. So if this if statement is true, it's going to do everything in between these two braces. If it's false, it's going to do everything between these two braces. Okay? So let's run this program. And we're going to enter in 42. I'm going to hit the enter key. I'm going to type in the number 0. And then when I hit the enter key, it says division by 0 is not possible. Please run the program again and enter a number other than 0. So do it again. So I run, I type in 42. hit the enter key, I type in the number 6, and it says the quotient of 42 divided by 6 is 7. Any questions on that? Okay. So, the next thing we're going to cover is this thing called nested ifs, and that's an if statement inside of an if statement. So in this particular case, here's the flow chart. It says if your salary is greater than or equal to 30,000, we're going to come into true. And the next thing we're doing is going to have another if statement that says if years on the job is greater than or equal to 2, if that's true. So if this if statement is true and this if statement is true, we're going to come down here and say you qualify for the loan. But if we come in here and if salary is not greater than or equal to 30,000, we're going to display you must earn at least 30,000 per year to qualify. And then it's going to drop completely out of the if statement. So it's going to follow this line here, print that, then come down here and drop completely out. It's not even going to look at this over here. But let's say this statement is true, so their salary is greater than or equal to 30,000, but they've only been at their job for 1 year. So it's going to come down this true path, come over here, and then come over to the false path, and it's going to display on the screen, you must have been on your current job for at least 2 years to qualify. Then it's going to come down here, follow this arrow, and drop completely out of the item. So let's open up the code loanqualifier.java. So over here back in Eclipse, we're going to double click on loanqualifier.java. And it looks like we're going to be using a JOption pane. So I've got my loan qualifier, which is my class. Here's my public static void main. I've got 3 variables. I've got double salary, double years on the job, and then string input. So I use a JOption pane to say enter your annual salary. I'll bring this down a little bit. Enter your annual salary. And then we use the double.parse double. Using the input to convert to a double, we put it into salary. Then I ask, I don't know why we did this. It says enter the number of years in your current job. We're going to get the input from that JOption pane dialog box. We're going to use the double.parse double to convert it to a double, and we're going to put that into years on the job. Then down here, look at this. I've got if salary is greater than or equal to 30,000. If that's true, it's going to come down to this if statement. If years on the job are greater than or equal to 2. So if that is true and that is true, it's going to display the JOption pane. You qualify for the loan. But if this guy is true and this guy is false, it's going to drop into this else statement, and it's going to display you must have been at your current job for at least 2 years to qualify. But if this first if statement is true or false, it's going to drop into this else statement down here, and it's going to say you must earn at least $30,000 per year to qualify. So once it executes one of these lines, it's going to drop completely out of this if statement. And notice that since we're using a JOption pane, we're using the system.exit0 to get completely out of this program and close any JOption panes that are running. So let's run this guy. And we're going to say, hey, I make 31,000 and I've been at my job for 1 year. Click OK. And it says, sorry, you must have been at your current job for at least 2 years to qualify. So let's run it again. And this time I'm going to type in 29,000 and I'm going to click OK. I'm going to enter years on a job of 1. I click OK. And it says that you must earn at least $30,000 per year to qualify. Notice it didn't even check the 1. I had 1 years. Because why? Once this is false, it did this else statement and then dropped completely out. Now let me show you how we can actually use the debugger for this. And the debugger is a really cool tool. So I'm going to do this. I'm going to do a right click on the number 24 right here for the if statement. If yours is a different number, then anyways, off in here I'm going to do a right click. I'm going to click toggle breakpoint. And when I do, in the margin over here, notice I got this little round ball. That tells me I have a breakpoint set right there. Now to run the debugger, we've always been clicking on this green circle with the triangle in it, but if you look left of it, there's a little picture of a bug, little icon of a bug. Let's click on that. And now we've basically gone into debug mode. We're not there yet because it has to hit this breakpoint and actually to go into debugger mode. So I'm going to type in 31,000. I'm going to click OK. Then I'm going to type in 1 and click OK. And now it says, oh, hey, we're about ready to go into the debugger mode, which we're going to go into what's called the debugger perspective. And I'm going to go ahead and click switch. And we're going to see this screen change. We're going to have we've now got a debug screen over here we automatically go into. And over here we now have this variables, breakpoints, and expressions. So I now have this thing called breakpoint. Now here's what's really cool. I have args, and that's basically up here in our public static void main, and we're not using those. But notice I have my variable salary, and it's got 31,000.0 in it. Years on the job has 1.0 in it. And my input, which is basically a string, has a double quote 1 in it, because that's the last thing we used. Now, for now, we're going to use, see these arrows that we got an arrow that's got it's a right triangle, it comes down. That's a step into. We'll cover that at a later point. The one next to that is kind of a curved arrow, and that's what's called a step over. We're going to use this one. And this is going to allow us to go one line at a time and execute. So let's click on it, and when we do, it's going to go to the very next line, which is if years on the job are greater than or equal to. Well, notice that we actually made it past this first if statement, because why? Our salary was 31,000. Now watch what happens when I click the step over button. I click step over, it automatically jumps down to the else statement. Why? Because years on the job is 1. It's not greater than or equal to 2. So this statement, this if statement right here, was false, which caused it to go into the else statement. So now when I click step over again, it has to execute that a couple times. It says you must have been in your current job for at least 2 years to qualify. I click OK. I notice that it automatically jumps down, and it shouldn't go to that else when I clicked on the L. Yeah. So automatically jumps out of the if statement, executes as system.exit 0. If I click step over again, you'll notice that the variables box is clear. These things over here no longer they're now black and white, which means they're not running, and the program has ended. Any questions on that? So let's run it again in debug mode. And this time let's type in 29,000 and OK. And this time let's type the number 3 for years of the job. I click OK. So over here we can see we've stopped at our breakpoint. I can see my salary of 29,000 over here in my variables dialog box. Years in the job says 3. So watch what happens now when we click on our step over. Boom, it automatically jumps down to the else statement. Why? Because this statement was false, automatically went to the else. So it's going to go ahead, again we have to click it a couple times, so step over. Yep, and there it is. You must earn at least $30,000 per year to qualify. Click OK. It jumps down to the system.exit 0. Again, notice this green arrow here, resume and terminate. When I click on the step over again, boom, the program is no longer running because those guys are no longer have color. They're black and white. Sure. Yes, you have. Right. You have to set a breakpoint in order for the debugger to go into the debug perspective. Now, let me do this. Now you don't have to follow. If you want, you can. But I'm going to run it again, and I type in, let's say, 29,000. I type in 3 years, and I click OK. And now I'm at breakpoint. Now, if you're in a situation where you're really trying to debug this program, guess what I can do? I can come over here to this guy here, my variable, and I can wipe that out. And I can type in 31,000 and hit OK. And now watch what happens when I run the program. So I click on step over, and it comes up, says you qualify for the loan. So this is a great, what this is good for is, let's say your program is doing, you're trying to test this program, and you've got this big, long, complex if statement, and you can't seem to get it to go through the if statement. Well, you can actually come over here and manipulate the variables to make sure that it falls into that one if statement you're trying to test. Does that make sense? Yeah. Now, since I just ran that, I don't want to go through I don't want to do step over anymore. I can actually click on this green arrow that's called resume, or I can hit the F8 key on my keyboard. I just click on that and the program resumes. In this case, it just hits the system.exit 0 and we're done. Here's what I do is I have an Eclipse book. It's a pretty old book, but I scanned the entire chapter on debugging. If I remember, if I forget, make sure you remind me. But I'll put the actual PDF out there for if anybody wants to kind of go through that, because you can really get detailed. You can use this expressions and this breakpoint, and you can really manipulate a lot of stuff in the debugger. It's very powerful, and that's all built into Eclipse. So, okay. Yeah, so they're kind of showing you here how the things kind of all go together, that this if statement goes with this else statement, and this if statement goes with this else statement. So I like these things, in the spotlight, multiple nested decision structures. It says, suppose one of your professors uses the following 10-point grading scale for exams. 90 and above A, 89 to 80 or 80 to 89 is a B, so on and so forth. So your professors ask you to write a program that will allow a student to enter test score and to display the grade for that score. Here's the algorithm that you'll use. Ask the user to enter the score. Determine the grade in the following manner. If the score is less than 60, the grade's F. Otherwise, if the score is less than 70, then the grade is a D. If the score is less than 80, it's a C. Otherwise, if the score is a 90, then the grade is a B. Otherwise, the grade is an A. Okay? So, and this is what the flow chart would look like for that. So again, we come in if the score is less than 60. If that's true, we're going to display F. If that's false, we're going to come into another if statement, so on and so forth. So let's look at the nested decision.java. So since we're right now in this debugger perspective, we could click right here on the Project Explorer, and now we're back to what we've seen before. Notice this variables and breakpoints expression still there, but we can actually change that back to the things we're using. I think it'll automatically change back. So let's expand chapter 3. Let's expand SRC. Let's expand the chap 3 package. And again, we're going to open up what was it called? nested decision. Nested decision.java. So here's our class nested decision. Here's our public static void main. We have two variables, int, so integer test score, and then string input. And then we're going to ask the user, why he kept doing that. So we're going to ask the user, enter your numeric test score and I will tell you the grade. And let me move this over. And it says, if test score is less than or equal to 60, J option pane, your grade is an F. And then what's going to do, it's going to drop completely out of that if statement. If that statement's false, then we're going to go into the else statement. Inside of there, we have an if statement. So we have a nested if inside of the else. So if test score is not less than 60, but the test score is less than 70, we're going to say your grade's a D. But if that if statement is false, that if statement is false, and this if statement is true, you got a C. But if that's false as well, and the test score is less than 90, your grade's a B. But if that's false, that's false, that's false, that's false, we're going to automatically assume that your grade is greater than or equal to 90, and your grade is an A. And again, since we use the J option pane, we're going to use the system.exit 0, drop completely out of this program, and close all J option panes and get out. Okay? Any questions on that before we run it? Okay. So let's run it. And we type in a test score. I'm going to type in 82. Click OK, and it comes back and says your grade is a B. Now let's do this. Let's put a breakpoint right here on line 22. This is where if test score is less than 60. Do a right click and click toggle breakpoint. And I'm going to click on the debugger, the little bug icon. And it's going to stop again. Okay, it's first going to ask for a score, and then it's going to go into the perspective. I'm going to type in 82. Click OK. Now it's going to automatically goes into the debugger perspective. I'm going to go here. Notice I can see test score 82. So I click step over. Now notice step over, I can also hit F6 on my keyboard if I wanted to. So it's 82, so the test score is not less than 60. Click step over. It's not less than 70. I click step over. It's not less than 80. But watch this. It says if test score is less than 90. It's 82. That should be true. And it goes right into that. Yep. So it's going to print that J option pane. Your grade is a B. There it shows that. We then drop completely out down to the system.exit 0, and the program ends. So we can kind of see it flow. We can see that, yeah, that was false, that was false, that was false, but that one was true, so it automatically executes that. Now notice we've got this stair stepping coming down. What if I had 30 if statements? Well, this thing could actually stair step right off the screen. And that's totally legal. We can do that. We just would have to scroll back and forth a lot to see the code. So, but let's take a look. I went too far. We have this thing called an else, if, else, or if else, if statement. The if else, if statement tests a series of conditions, and it's simpler to test a series of conditions with the if else, if. So, what does it look like? Well, I've got my if statement. Here's my open brace, closing brace. And then on the same line, I've got else, if. And there's my expression, and then it's going to do those. Okay? So, let's take a look at testresults.java. So let's click over here on Project Explorer, and I should see testresults.java. And here is that same program we just did, except look, now we're using what's called an if-else-if. Now look how uniform it looks. So look at this. It says if test score is less than 60, we're going to execute that. So if that's true, we're going to execute that. Else, if this statement is true, we're going to do that. Else, if that's false and that's false, we're going to do an else if here. Now, like I said, I like to use the braces. Again, you don't have to do this. I'm just going to do it for my own benefit. But I can actually put my open brace right here, and I can put my closed brace right here in front of the else, and then put my open brace right here at the end of that if statement, and again right here in front of the else. Again, it's not needed since we only have one executable line of code within our if statement. Again, I like to use the braces because it shows me what goes with what if. Again, not needed. And I have this argument with other programmers. I said I like to use it, and they go, it's not needed. Don't write extra code you don't have to write. And I'm going, well, that's just my own preference. And they go, well, then don't write it. I said, okay, you do you, I do me, we'll do fine. Okay, so as you can see, as we look at the difference between this and this, we can see it's a lot more compact. It basically keeps everything aligned to the left in one columnar format. A lot easier to read. We just basically combine the else and the if together. Over here we can see that they are actually separate. I got else and then else and if on two separate lines. This is going to execute the same exact way. When I run it, I type in an 82, click it, it says your grade is a B. So we get the same exact results, except it's just a lot cleaner. Kind of like I said the first night, is writing code, the best way to write code is make it maintainable. The more maintainable you can basically write code, the better off it is. Again, your company that is paying you as a programmer to write code, if it takes you a half a day or a day just to figure out what the code is doing because it's so unorganized and kind of code all over the place and uncomments, you don't use comments, then it really is an unmaintainable code. But if you put good comments in there and you organize it with else ifs, an if else if, then it makes it a lot cleaner, a lot easier to understand. Again, the braces, again, that's just another argument somebody wants to have, but the braces also show us where the if statement starts and where the if statement ends. So any questions on the if, else, if? Correct. It's just like an if statement. They are inclusive. Only this J-option pane line right here goes with this if statement. Only this one goes with that if statement, and only this J-option pane goes with that else in this case. So if this guy is false, and this guy is false, and this guy is true, only this J-option pane executes, and then it drops completely out. It's a good question. A lot of people ask, well, what about this guy down here? Well, no, it won't go into that if statement because that's another thing people try to look at as well. They say, well, if I got 82 is my, well, let's say I put in 72. Well, that if statement is true, and that if statement is also true, and that else statement is actually true as well. But once it executes this J-option pane right here, it's going to drop completely out of this if statement. There's nothing else to execute an if statement. Now, I want to talk about the trailing else statement to catch errors. Let's say the test that we're utilizing, the maximum score you can have is 100. Well, this guy right here, I could have 110 and it's still going to show an A, right? Well, we might want to write this code to basically check for errors. Maybe somebody typed in a wrong code. Maybe they were to type in a 62 and actually put a 1 in front of it and said 162, and that person would get an A. Well, we want to catch that error somehow, and how we would do that is we'd use this thing called a trailing else. Now, we've got a trailing else right here, but it's just going to catch everything that is greater than or equal to 90. But like I said, what if we wanted to make sure it didn't go higher than 100? So we can use the trailing else logic for that. So we're going to use this trailing else.java. Let's look at that guy. And there I've got my int test score on my string input, because we're using a JOption pane. And I say JOption pane, enter your numerics test score, and I'll tell you the grade. And we go ahead and convert that from a string to an integer and put it in the test score. Then I come down here and I say, if test score, so everything up to this last else if is on the other program. The only thing we've added this time is else if test score is less than or equal to 100, we're going to say your grade is an A. Else, we're going to type that is an invalid score. So let's say as an instructor, I accidentally put a 1 in front of the 62. This is going to tell me, oh, that's an invalid score. Oh, I meant to put in just a 62. And then I could basically correct my answer and then basically run this program again. So again, so if we run this, and I type in 110, it comes back and says that's an invalid score. We might have, again, as we're running these programs, we always want to type as much information as we can. We could say invalid score must be less than or equal to 100. Because this invalid score is kind of vague. But again, we're learning Java right now, and they're trying to basically give us just the basics. But in the real world, we really want to give our users a lot of data. If it's an invalid score, we want to explain why it's an invalid score. If I just say invalid score, they don't know what they did wrong. We need to kind of explain to them what they did wrong. So the trailing else in this case, we want to make sure that everything we type is less than or equal to 100. And if they typed anything above 100, that's an invalid score, and we want to display that. So that's kind of what they're talking about, the trailing else, checking for errors in this case. Okay. This next section is also very important. There was a guy named Boolean. Boolean was an actual, he was an algebra expert back in 100 some years ago, and he developed this whole thing called Boolean logic. When I got my first degree in computer science, we had to take a whole class on Boolean logic. We had AND gates, OR gates, NOR gates, and all this kind of, we had to use these special symbols and all this kind of goofy stuff. But anyways, we're just going to touch on just a slight part of Boolean logic in this section right here. So Java provides two binary logical operators, the two ampersands and the two pipe symbols, which are used for combining Boolean expressions. So the two ampersands together is what's called an AND statement. the two pipes together is the or statement. And the exclamation point is the not. So it's a way for us to say if it's a not equal to something. So if I had this statement, X greater than Y and A less than B. Now, let me say this. Whenever we have an AND statement in Boolean logic, that says everything on both sides of this AND statement have to be true in order for the entire expression to be considered true. So for this statement to be true, X has to be greater than Y and A has to be less than B. Then this entire thing is considered true. Now down here I've got X equal to Y or X equal to Z. With an OR statement says only one of these items on either side of the OR has to be true. Only one of them does. If one's false and one's true, the entire expression is considered true. So if X is not equal to Y and X is equal to Z, that whole entire statement is considered true. We've got the not statement. We could say if X is not greater than Y. Now, I would never, ever, ever want to see this statement ever in my life. Because that statement, because not logic, I really do not like not logic. And the reason for it is this is hard to read. What this is really saying is X less than or equal to Y. That's what that statement's really saying. And that's why I try to stay away from not logic, because it's really, so if X is 10 and Y is 12, is that statement true? 10 is 10 greater than Y, but it's not. It's, well, let's see. So it's really, it really blows my mind trying to figure this out. The way to do this is this statement should just be X less than or equal to Y. So, okay. Now to continue on, know that this one, if this is true and that's false, the entire thing's false. If that's false and that's true, then the entire thing's false. If that's false and that's false, the entire thing's false. But if that's true and that's true, the entire statement's true. So just like up here. If that's true and that's true, the entire thing's true. But if that's true and that's false, the entire thing's false. So let's take a look at the logical and.java. So we take a look at the double. So we got the logical and. Here's our public static void main. I've got double salary, double years on job, and string input. So I got three local variables. So I'm using a JOption pane, enter the annual salary. Again, we put that in input. Input's a string, so we need to convert that to a double. So we use double.parse double input, convert that to a double, put it into salary. I've got input equals JOption pane into the number of years in the current job. I take that string, convert it to a double, and put it into years in the job. So now I have those two variables that have data in it. Then I say, if salary is greater than or equal to 30,000 and years in the job are greater than or equal to 2, we're going to say you qualify for the loan. If either one of those are false, either one or both, it's going to drop down into this else statement and say you do not qualify for the loan. So if we run this, and I'm going to type in 29,000, I'm going to type in 3, it comes up and says I do not qualify for the loan. Now the bad thing about doing this way as opposed to the other way The other way at least tells us, since we have two if statements, it does tell us why we don't qualify for the loan. You might say we don't make enough money. This way here, it's very generic. It says you don't qualify for the loan. Because if we run it again, and this time I type in 31,000, and I type in the number 1, it says you do not qualify for the loan. And again, I don't know why, but I just know I don't qualify for the loan. If we run it one more time, and this time I'm going to type in 31,000, and the number 3, that we do qualify for the loan. So I do. So what that did is this statement was true, and this statement was true, and so we basically went into here. Again, since it's an and statement, they both have to be true. Everything on both sides of that and statement have to be true. Okay. Any questions on that so far? So now let's talk about the OR operator. And again, the OR operator is different than the and the OR operator says only one of these items has to be true in order for this entire if statement to be considered true. So, temperature less than or equal to 20 or temperature greater than or equal to 100. If both of those are false, that means the temperature is in a danger zone. So let's say the temperature was 10. Well, is 10 less than 20? No, it's not. Is 10 greater than 100? No, it's not. So that entire statement's considered false. Let's come down here. But let's say it's 50. Is 50 less than or equal or less than 20? No. Is 50 greater than 100? No. Oh, I'm sorry, I'm reading this wrong. But anyways, let's take a look at logical OR. Click Project Explorer and logical OR. It'll make more sense once because I was reading that last one wrong. Okay, so logical OR is the name of our class. Public static void main. Got the same exact program, except the if statement down here is different. We've got salaries on the job, or salary, years of the job, and input. We're going to use a J-option pane to enter salary. We're going to convert that input into a double, put it into salary. We're going to ask for the number of years in the job. We're going to convert that string into a double, put it into years in the job. Now this time, if salary is greater than or equal to 30,000, or, that's an OR statement right there, 2 pipes, or years in the job is greater than 2. Only one of those, either one of those has to be true. If they are, this if statement is true and we qualify for the loan. So, I'm going to put a breakpoint right here on this if statement. And I'm going to click on the debug mode. And when I do, it comes in, enter your annual salary. I'm going to type in 29,000. Years in a job 3. Click OK. Now, over here it shows salary of 29,000. Years in a job 3. Well, this statement is false. My salary right now is 29,000. That is not greater than or equal to 30,000. I look at years in the job. Years in the job is 3 greater than or equal to 2. It is. While I'm in debug mode, I can actually hover over the variable that's going to tell me what's in it. This has 29,000. I go to years in a job, it shows 3. That statement is true. Since this is an OR statement, either one has to be true, and this entire if statement is considered true, and it's going to go into this J-option pane you qualify for the loan. So I'm going to step over it. There it comes up, you qualify for the loan. I hit the system exit 0 and the program basically no longer runs. Let's run it again. I'm just going to run it this time. I'm going to type in 32,000. I've only been in a job for 1 year. I click OK, and it says you qualify for the loan. My salary was 32,000. Is 32,000 greater than or equal to 30,000? Yes, it is. Is 1 greater than or equal to 2? No, it's not. But since this is an OR statement, only one of these had to be true, and this entire if statement is considered true. Now, I want to run it one last time. This time I'm going to put 29,000 and 1. And now it says I do not qualify for the loan. Why? Because 29,000 is not greater than or equal to 30,000, and 1 is not greater than or equal to 2. So neither one of those were true. Both sides of this OR statement were false, so this entire if statement is considered false. So it basically says you do not qualify for the loan. So any questions? Right, exactly. It's Boolean. That's Boolean. That's considered Boolean logic. We do have the exclamation point. That's the not operator. And so if I have something that's not true, then it's false. If I have something that's not false, then it's true. So I could do something like this. I could say, if salary is not no, I can't do it that way, can I? I could say not equal to 30,000. Or I could do this. Now here's how I'd have to do that. I could do a exclamation point. So I could do if not salary is less than 30,000. That means it has to be greater than or equal to 30,000. I could do it that way, and that's ugly. Again, that just does not make sense to me. But that's how we would use the not logic. So that right there and this are the same exact thing. The only time we really use not logic is not equal to. So that would be the best way to utilize it. So it talks about the precedence of comparison. What's going to happen first? Well, the first thing it's going to do, it's going to take care of any negative numbers. Then it's going to do multiplication, division, or modulus, whatever comes first. It's going to do any addition or subtraction, whichever comes first. It's going to do any less than, greater than, less than or equal to, greater than or equal to, again, whatever comes first. Then it's going to do any equals or not equals, whichever comes first. Then it's going to do any logical ands. Then it's going to do any logical ors. Then it's going to do any assignment, which is the equal, plus equal, minus equal, so on and so forth. So that's the order of operations when we utilize any logical ands or ors and that type of thing. So let's say we wanted a number that was between 20 and 40. We can actually utilize an AND statement for that. So I can say, if x is greater than or equal to 20 and x is less than or equal to 40. That means if both of those statements are true, then we truly have a number that is between or from 20 to 40. Because it could be 20, because we got a greater than or equal to. It could be 40. But if it was, let's say, 37, is 37 greater than or equal to 20? Is 37 less than or equal to 40? Both of those statements are true, then it would print is an acceptable range. Make sense? Okay, so up to this point, we've pretty much covered any primitive values. How do we compare strings? Well, strings, if you remember, are not just a primitive where it's just face value what it is. A string is an object. There's a whole lot of other stuff behind the scenes going on there. So we can't just use an equal sign or a greater than or any of that type of thing. We have to utilize different items for comparing string objects. So let's say I had a string object name 1 and string object name 2, and the first one had Mark in it, the other one had Mary. And if I have if name 1 is equal to name 2, well, it's going to be false because one has Mark, one has Mary. And so, and again, since they're objects, and objects have a lot more things going on behind the scenes, and one of those items that's part of an object is something called a hashtag. And the best way to explain what a hashtag is every object has its own social security number. And that social security number is called the hashtag. So guess what? Every object has a different hashtag than the other object. So if I have two objects that have, let's say I have name 1 and name 2, one has Mark and the other one has Mark in it. If I try to compare the two, it's going to basically not equal because that object's hashtag. Everything else will equal except for that hashtag. So we can't just do an equal when we use string objects. What we need to utilize is a string has a built-in method called equals. There's an equals method that's built into it. So let's open up stringcompare.java. Click on the Project Explorer, and there is string compare. And name of my class is called string compare. Public static void main. I got string name 1 is equal to Mark, name 2 is equal to Mary, and name 3 is equal to Mary. So I say if name 1 dot equals name 2. So again, the string class has a method called equals. I put name 2 in the parameters inside the parentheses of this method, and it's now going to truly compare the text in name 1 to the text in name 2. And it says, if that is true, so if this statement right here is true, it's going to print name 1 and name 2 are the same. If that statement is false, it's going to automatically drop into the else statement, and it's going to print name 1 and name 2 are not the same. Then it's going to check to see if name 1 and name 3 are the same, so dot equals. If they are, it's going to print that they are the same, else they aren't the same. And that's going to basically drop out. Oh yeah, name 1 is Mark, name 2 is Mark, and name 3 is Mary. Okay, so let's run it. And Mark are the same. Mark and Mary are not the same. So How did that work? So I'm going to put a breakpoint right here. I'm going to do a right click on the 1, 3, line 3. I'm going to click on toggle breakpoint. I'm going to click on the debug icon, and we automatically go into the debug mode. So I look over here in my variables, and I can see name 1 has Mark, name 2 has Mark, name 3 has Mary. So when I use the dot equals, it's going to only look at the text that is in each of those strings. So in this case, it's just going to compare Mark to Mark. If they are equal, the equals method will say they're equal. It'll actually return true, and it's going to print name 1 and name 2 are the same. Down here, we're going to do Mark, compare it to Mary. If they are equal, it's going to print they are the same. Else, it's going to print name 1 and name 3 are not the same. So I'm going to step through this. I'm going to click my step over, and you see it pops in, sys out. So it prints Mark and Mark are the same. It drops out of that if statement, goes automatically to the next if statement. It's going to see if name 1 is equal to name 3. Is Mark equal to Mary? I step over it, and it automatically jumps to the else statement. And when it prints that, it says Mark and Mary are not the same. And it basically drops out of the program. So we cannot use the double equal sign for strings. We can only use the dot equals method that is built into the string class. Any questions on that? Now, again, here's an example using not logic. If I say if not name dot equals Mark, so it's saying if name does not equal Mark, if that statement is true, meaning they do not equal. So that would basically be doing this down here is if not name 1 equals, then we're going to say they are the same. That's not what we want, but I can actually flip-flop these. So I could put down, you don't have to do this, you just watch me. I'm going to cut that guy out, put it down here, and then move this guy up here. So it says, if name 1 does not equal name 3, we're going to print they are not the same. Else, we're going to print they're the same. So now when we run it, it says Mark and Mark are the same and Mark and Mary are not the same. But if you look, this is ugly. Not logic is, I just don't like it. It's necessary sometimes, but for the most part, I try to avoid it. Because, yeah, not name equals name 3. It just, yeah. It just doesn't flow like it should. Another thing we can use is thing 2 called compare to. Okay. Compare to is another method that is built into the string class. And what it does is it compares one string's text to another. If they are equal, now a compare to is going to return a primitive value. It's going to return either a -1, a 0, or a +1. And here's how it works. If they're equal, it will return a 0. If the first one is less than the second one, it's going to return a -1. If the first one is greater than the second one, then it's going to return a +1. So let's take a look at the string compare to.java. So here I've got string name 1 equals Mary, and name 2 is equal to Mark. So I have two string objects, name 1, name 2. I say if name 1 dot compared to name 2 is less than 0, I'm going to say name 1 is less than name 2. Else if name 1 dot compared to name 2 is equal to 0, we're going to display name 1 is equal to name 2. Else if name 1 dot compared to name 2 is greater than 0, we're going to say name 1 is greater than name 2. Now if we look at this, here's how it's going to do the compare. I'm going to go back to the book for a second. It's going to look at the first two letters. They're the same. It looks at the next two letters. There's the same. Looks at the next two letters. They're the same. Then it looks at the last two and it sees that Y as greater than K. So name 1, in this case, will be greater than name 2 because that last character is greater than K when it looks at it into the hexadecimal format. So when we run this, we can see that Mary is greater than Mark. Now, if I were to change this Y to a K, and then save it and run it, it says Mark is equal to Mark. If I change Mary over here, so Mark and then Mary, and save it, run it, now it says Mark is less than Mary. Does that make sense? So in that case, go ahead. Yeah. So basically, it's basically doing this. It basically says, and it's comparing letter by letter, and since that last letter is, in this case, K is less than Y, and here's what happens. We use the compare to. Since name 1 is less than name 2, when the compare to, it basically returns a -1. And so this statement gets executed. Name 1 is less than name 2, and that's what's displayed down here. Mark is less than Mary. Any questions? So let's take a look at this last, we'll cover this last program before we kind of work on the lab a little bit. It's called secret word. Let's come over here to secret word. So here's our secret word class. We've got public static void main. We've got string input. We're using the scanner keyboard this time. We ask you to enter a secret word, and then we take the keyboard next line, put it into input. If the input, now, let me go back over here for a second. We have this thing called ignore case in the string comparison. And what that is we have dot equals, so we have an equals method, and we also have an equals ignore case method. And what that's going to do is that's just going to compare to see if there's a P and R, O, S, and it doesn't care if one's uppercase or lowercase. And I'll show you the difference here in just a second. So we go back over here, so I've got if input dot equals ignore case Prospero, congratulations, you know the secret word. If it doesn't equal Prospero, it's going to say, sorry, that is not the secret word. So let's do this. Let's run it. And I'm going to type all lowercase P-R-O-S-P-E-R-O. Now notice this is all uppercase. This is all lowercase. But since I have equals ignore case. There's a method that says I'm not going to worry about case. I don't care if it's uppercase or lowercase. I'm just going to compare the letters. That's what this method does. So when I run it, it says, oh, PROSPERO. I hit the enter key and it says, congratulations, you know the secret word. But I'm going to use just the equals method. I'm going to get rid of this ignore case because that's a separate method altogether. I'm going to use just the equals method. And when I run that, watch what happens when I type it all lowercase. PROSPERO. I hit the enter key and it says, sorry, that's not the secret word. Well, even though I got the word right, it's in the wrong case because equals actually looks at each letter in their proper case. It looks at both of them to see if it equals each one of these letters uppercase. So it's looking at the uppercase. But if I use the ignores equals ignore case, then it's just going to look at the letter itself and ignore if it's uppercase or lowercase. So PROSPERO, hit the enter key and congratulations, I know the secret word. So we use the dot equals, and we also have the dot equals ignore case. Any questions on that? Right.